Good day to my lecturer and my fellow classmates. My name is GEVEGANESH, son of SHASITHARAN from BMMM 1/1. So, in this pleasant day, me and my teammates will be presenting you our assignment 2. The lab we have chosen for our assignment is Kinematic Viscosity. Let me start with the objective of this lab experiment. The first objective will be to understand kinematic viscosity measure method. The second objective of this lab is to determine viscosity index of lubricant sample. The third objective for our lab is to understand grade of lubricant oil based on the viscosity. That's all from me. Thank you.
Good day everyone. My name is VISHNU JAISEELAN. My material number is B0920104006 and I'm going to present about the methodology of Lab 1 kinematic viscosity in the subject oil and wear debris analysis. As per we can see from here, for the methodology part, there is a flowchart has been constructed to uh, make sure the procedures are followed in this experiment. For the start, we need to prepare the equipments and tools which is going to be a part in the procedures and works for this experiment, which is viscometer, Kitawa viscometer, oil samples, tissues, and cleaning objects and beakers. And for the first part, we need to clean the Kitawa viscometer. For that, we need to pull out the sliding plug at the top of the viscometer, as we can see here. There's a sliding part right here. Then we need to clean up the Kitawa viscometer inside and outside from any contaminant with tissue paper. And for the next step, we need to pour the oil sample inside of the viscometer. And for that, we need to measure at least 200 milliliter sample of oil using beaker. Then we need to pour it like this into the viscometer above the V plate. As we can see, there is a V plate inside the viscometer for measure the level. And we must place it vertically for make sure the oil not spill from the viscometer because it is slanting in shape. And for the next step, we need to select the modes before the tilting and other process. And for that, firstly, we need to select the mode 1 and use speed and arrow keys to set the density of oil, which is 850 for this experiment. And after that, we need to select the mode 5 and press return to save the oil density, which is the next step, which is mode 5. There is we need to set the 100. And for the third step, which is mode 2, where we set the temperature 40 Celsius. Then we need to confirm and press the return key. After all the selecting modes are set, then the oil will be heated until 40 degrees as we set in the mode 2. So after the oil temperature come up to 40 Celsius, then the viscometer will show tilt. After that it shows, we need to tilt the viscometer when it prompted anytime it shows. So after 2 or 3 steps we need to tilt, then it will show the viscosity of oil at 40 degrees and 100 degrees. And there we need to toggle the display viscosity, use the arrow keys up and down. Then after that, after every 2 or 3 readings we need to get as we desired, we need to record the readings. And after all, we need to finish with cleaning process, like using the tissues and take the oil out from the viscometer and make sure the ball inside the viscometer do not fall down and break anything, and make sure it is in good condition after clean up the viscometer. And that's all for the methodology part. Thank you.
Hi, my name is Wong, matrix number B0920100016 from 4BMKMS1/1. For result and discussion, the equation for viscosity index is L minus U over L minus H times 100. U is kinematic viscosity of the oil at 40 degrees Celsius, and value L and H can get from table 1. First, We put the data get from the experiment, which is the kinematic viscosity at 40 degrees Celsius, into the viscosity index equation and use kinematic viscosity at 100 degrees Celsius to find the value of L and H from the table 1 to calculate the oil's viscosity index. For sample A, the kinematic viscosity at 40 degrees Celsius is 111.3 CST, while at 100 degrees Celsius is 12.2 CST. Hence, its viscosity index is 99.38. For sample B, the kinematic viscosity at 40 degrees Celsius is 155.5 CST, while at 100 degrees Celsius is 15.3 CST. Hence, its viscosity index is 99.08. The viscosity index is an arbitrary, unitless measure of a fluid's change in viscosity relative to temperature change. Oil with high viscosity index experience less change in viscosity with temperature variations compared to oil with low viscosity index. As a result, sample A and B have a strong viscosity index, means that they exhibit a strong resistance to viscosity changes with temperature. Thank you.
Hi, Assalamualaikum. My name is BASHIRAH KAMARUZAMAN. So for the conclusion, firstly, the experiment provided value insight into the procedure for measuring kinematic viscosity. A key aspect is in assessing the flow characteristic of lubricant under the influence of gravity. This understanding is crucial for evaluating lubricant performance under various temperature conditions. Second is the study effectively determined the viscosity index of the lubricant sample, with sample A exhibiting a viscosity index of 99.38 while for sample B 99.08. This high value indicate a relatively stable viscosity across temperature changes, an important factor for lubricant use in environment with varying temperature. Lastly, for grading of the lubricant oil based on viscosity was truly accomplished, which is sample A was clarified as SAE 30, indicating a lower viscosity at higher temperature, making it suitable for application required quicker fluid flow. While for sample B, with a SAE grade at 40, suggests a higher viscosity at elevated temperature. So sample B suitable for application where a thicker lubricant is beneficial. Thank you.